So in this video, I'd like to give you a couple of redox equations to balance and try your hands at. So let me go ahead and write them out up front. So ClO minus reacts with chromium OH4 minus, so that's a complex ion, and it forms chromate and chloride. And we're going to say that this occurs under acidic conditions. So pause the video and go through those rules we did in the last video and see if you can't come up with this balanced equation. If not, just kind of unpause it and we'll work through step by step together. Are you ready? Go. Okay, so the very first thing we'd have to do is assign oxidation states. And we can immediately assign chlorines because it's a monatomic ion as -1. There's no elements in here, so we don't have to deal with that. We know that oxygen is almost always -2 in compounds, unless it's a peroxide or facing off against a fluorine. So we can assign lots and lots of oxygens there. Let's see, the chlorine and ClO, well, if it all adds up to -1, and that's -2, that means that chlorine must be +1, right? So we can immediately see the chlorine went from +1 to -1. So was it oxidized or reduced? And the answer is it went down, so it was reduced. So I'm guessing the chromium probably changed in oxidation state, so let's see if we can figure this out together. One thing we can do is we can remember that the OH- ion, the hydroxide ion, is OH-. So if we've got 4 OH- ions, that would give us 4 negatives. So if it adds up to overall of 1 negative, the chromium would have to be +3. We could double check our math. Hydrogen in compounds is always +1, so we can try that. So -2 and +1, okay, that's -1, times 4 is -4, plus 3 is -1. Yeah, looks good. Over here, it's a little bit easier. We got 4 minus 2, so that's -8. It adds up to -2, so that has to be +6. And remember, oxidation states apply to the individual atoms, right? Not to the groupings of them. We never double them if there's 2 or triple them if there's 3, only when we're checking our math with the charges coming out. So now we've got our overall equations. We can go ahead and separate them out into half reactions. So we've got the ClO minus, and I'm going to leave off state symbols, going to Cl minus. And let's see, the chlorine is going from +1 to -1, so that was our reduction. And then the other one we had was the chromium. I'll leave a little bit of space here. So chromium is going from the +3 to the +6 oxidation state. Okay, so if it's going up, then it is being oxidized. Awesome. Then we go through the rules. So the first rule is we balance everything but oxygen and hydrogen. So there's 1 chlorine, we're good. There's 1 chromium, we're good. Okay, so now we balance oxygen using waters. So we've got an oxygen on the left, we don't have on the right, so we need an extra oxygen on the right by adding a water. For this equation here, we got 4 oxygens here, we got 4 here, so we're golden. Then we balance hydrogens using H pluses, so we've got 2 H's on the right, we don't have 2 on the left, so it's unbalanced, so we need 2 H pluses. Now down here, we got 4 H's on the left and 0 on the right, so we need to add 4 H's. Okay, you always got to remember to balance the water before the hydrogen, otherwise you're going to be in big trouble. And then the last thing is the charge. The charge trips people up all the time. You got to always add the electrons to the more positive side. So you got 2 positives and a negative, so that's +1. This is -1, so the more positive side is here. And the difference between +1 and -1 is 2. So I need to add 2 electrons to this side. You can kind of think of it as a number line, right? So if +1 is here and -1 is here, the gap, of course, is 2 between there. And then the last equation here, we've got a -1. And, well, that would be -2, but we got to remember we've added 4 positives. So that gives us +2 and -1. So +2 is 3 units bigger than -1. So we got to add 3 electrons to the right-hand side. And if we add everything up, we can quickly check. So 4 positives, 3 negatives, that's +1. And a -2 is -1, and there's a -1. So we don't have to get each side neutral. We just have to get both sides identical in charge. The next thing was to sum them together. Now, if you look at these two equations, if we add them together, we are not going to get cancellation of electrons because we got 2 on the left and we got 3 on the right, so we'll get 1 left over. We're aligned to multiply, and we probably want to look for sort of common factors here. And of course, if we triple that one and we double that one, we'll get a common factor of 6 electrons. So we get 6 electrons in the top and 6 in the bottom, so they will cancel out. Okay. I'll put my arrow in the middle and I'll write my 6 electron transfer over. So if I triple 2, I get 6 hydrogen ions. And I get 3 ClO minus ions. And then the bottom equation, I got 2 of these chromium funky things. And that's everything on the left. Now on the right, I got chloride, but I've tripled it. And I got water, I've tripled it. So I got to remember I've got not 1, but 3 chlorides and 3 waters. And on the bottom of the equation, I got 2 chromates. 4 hydrogens doubled becomes 8 hydrogens. And actually, we can do a little bit of cleanup here because look, we got 6 hydrogens here. We got 8 hydrogen ions here. So actually, we've got 2 more on the right than the left. So I'm just going to go ahead and erase my 6 here. And I'm going to change that 8 to a 2, and I think that is going to be much cleaner. Anything else? Well, I guess if I erase that, I need to get rid of the positive, don't I? So there we go. There's no more plus. And I've got waters on one side, not the other. So I don't think there's any more cleanup I need to do. And it was under acidic conditions, so I think we're good at this point. But we should probably double check. So we should check its balance. So we got 3 chlorines and 3 chlorines. We got 3 oxygens there. We got 4 inside every one of those. 2 of them means there's 8 oxygens. Plus those 3 is 11. So let's count. 1, 2, 3. 4 times 2 is 8. 8 plus 3 is 11. So that's looking good. We've got 2 chromiums, 2 chromiums. We've got 4 hydrogens. Oh, times 2, that's 8. 3 times 2 is 6. And another 2 is 8. So that looks pretty good. One last thing, though, the charge. We got 3 minuses and 2 minuses. It's 5 minus on the right. The left. On the right-hand side, we've got 3 minuses. 4 minuses there, so that's 7. Is that right? I think so. And then 2 positives, that takes it down to 5 minuses, 5 minuses, 5 minuses. Perfect. So we've got a nicely balanced equation. All right, let me give you one more to try, and I will just write down the answer for you in a second or two, but I think it's worth making sure you know how to do it. So here's a very fiendish one for you, and this is under basic conditions, by the way. So see if you can't balance dichromate plus iodine goes to chromium 3 plus iodate under basic conditions. And just pause the video and then have a go. And I will simply write the answer down underneath it. And if you've got any questions, come see me. All right, so I'll just give you the bottom line here. So when you balance this one out, you should have ended up at the end of the day with Did you get it? If so, very well done. That's a very tough one.